Very good. So we're going to talk about truth tables today. Recall that for simple statements, we have P, Q, R, A, B, and our goal is to form compound statements using the connectors like not, and, or, if, then. To each statement like P, we can assign a value like a truth value or the false value. So if we combine two simple statements like P and Q, then we expect to have 4 combinations. Since we have 4 combinations, we will use a table that we call a truth table to write all possible combinations in a nice and compact form. So let us begin. We have not, and, or, if, then. We're going to introduce 1, 2, 3, 4 truth tables. So let me erase this part of the board. I need some space to introduce these truth tables. Truth table for negation. Okay, the negation, the connector negation was introduced as not. The meaning, not the case that. Let P be a simple statement. The table is like this. Since you have one simple statement, you only have 2 combinations. Since we have one simple statement, then we have 2 raised to 1, 2 raised to 1 simple statement, which is equal to 2 combinations. Okay. For your table, when you're constructing the table, you write down the values for your statement on the first column. P is your statement. It goes on the first column. This is the rule that we follow for logic. So you have P. P can be true. Also, remember that P as a logical statement can be false. Okay, very good. Not P. Not P is going to be your second column. This is new. This is your new column. Take a look at the value of P. If P is true, not P is false. Very good. Okay. So again, if the value of your original statement is true, the value of this new statement is false. That makes sense. However, if the value of your statement is false, then the new statement, not P, is going to be true. Okay, very good. Give us an example. Let's take a look at a very simple example. Suppose I give you the statement like this. We're going to just investigate something very simple. Suppose I give you statement P, and I say that, hey, the statement P mentions that 1 plus 1 is 2. So this is my statement. We already can check the truthness or falsity of this statement. 1 plus 1 is 2. Yes, of course, it's always true. So this is a true statement. What about not P? Okay, I can easily construct not P. Not P says 1 plus 1 is not 2. Well, we already know that this is a false statement. This is a false statement. So this is the very first scenario. If your original statement is true, its negation is going to be false. Another example for you. In this example, we have P, statement P, which is defined as square root of 2 is rational. Well, we all know that square root of 2 is irrational. So this statement is already false statement. This is a false statement. Well, if I construct its negation, not P says square root of 2 is not rational. It's not rational, okay, which is a true statement. This is a true statement. This is this scenario. If P is false, its negation is true. We call this little table the truth table for negation. So we just learned something new. Truth table for negation. Later on, we're going to discuss the truth table for and, then or, and then we're going to introduce the truth table for implication.